everyone, I'm Miga and welcome to my channel. So today we'll learn about how to draw the chair conformation of a cycling compound, more specifically of a cyclohexane, okay? So first, before we get into it, let me show you what a chair structure, the chair configuration of a cyclohexane, at least the backbone look like when we actually build it. Here is a structure that I built using my regular model kit that I bought on Amazon. Again, here there's exactly 6 carbon connected, and now they are adopting that shear conformation, that shear structure, the same one that I showed you on the intro. Again, each little center should represent a carbon, but of course, carbon can make 4 bonds. So that means I should really put hydrogen here. But guys, I'm not focusing on the hydrogen. I just want to show you the structure and how to draw this, okay? So that's what we're going to try to reproduce. And guys, can you see how the shadow of this chair resemble an hexagon? You might be familiar with this structure too, but again, we're not going to focus on the shadow. It's the chair. Now, let's learn how to draw this on paper so that on the exam, when we're going to have to draw it to add or substitute, we can be clear, accurate, so everyone can understand us. All right, let's do this. To draw the chair conformation of a cyclohexane, first, guys, you're going to do a V, a wide V. Let's call this VA. And then you will make a lane parallel to half V. For example, first, let's do one that is parallel to half this V. Again, it's not going to be perfect, guys, but I'm showing you the pattern that we're trying to follow. You're going to do something that is parallel to the V. So let's call this lane B. And then let's connect V, VA, and B together. Let's connect them. That's one. And then we're going to connect the other side. But we're not going to connect them. We're gonna follow a specific pattern. First, we need to make a lane that is parallel to lane AB, to this lane. We're gonna make something else that is parallel here to lane AB. Okay. And finally, we can close it. We can close the two like this. Okay. Once you have this structure, remember, guys, we can also flip or check conformation. But you know what? To get what I'm saying, let's complete this structure. Let me remove A and B because they were only here for reference. Let's add the different position of the substituent can occupy. That means the actual position and the equatorial position. First, let me do all my actual position in purple. So we have 1, 2, 3, 4, 5, and 6. Remember, guys, it's all about alternating. Again, if you start with the actual that is up, you have to, the next one will be down, okay? Oh, let's give some numbering to make it easier to. Again, I like to start here as my first carbon. I like to say that this one is my first carbon. And of course, you can say this one is your second carbon or that one. But for me, I really like to stay clockwise unless I have to, because it's all about consistency in organic chemistry. So 1 and 2 and 3 and 4 and 5 and 6. That's one, right? And then now let's do the equatorial position in the color. We're gonna let's do it in green. Why not? Equatorial position. Again, I'm gonna start down. Oh, doesn't have to be that one. So we have 1 equatorial, 2. So like I like to make sure that it's up so that everyone knows I'm talking about up. Another one, 3, 4, 5, and 6. Again, to make sure that it looks even nicer, Let me make sure I'm not gonna break the connection so that you guys can see that I reproduced exactly what we saw, right? Let's connect this. That one is good. Oh, that's a purple here, but it's in the back, so I'm gonna mess this up. So here, guys, is one of the chair structure that you can build on the exam. Again, don't worry about these, guys. Those are simply position. They are not carbon. This any of these places can be X, any X substituent. For example, at carbon 1, we can have an hydrogen here. We can have a bromine here. It's up to you. But I'm just showing you different position of those chair structure. Now, let me show you how to draw the other version of the flip version of this one. That means when you see the side here, you can flip it so that one point down and this other side point up. Okay? Let me show you how to draw it. To draw the other version, I'm going to follow the same pattern. First, I'm going to do a nice V. Okay? Let's call this one VX. All right? And then I'm gonna make sure that I draw another parallel lane. Let's call this lane Y, but it's gonna be this time, this lane Y is gonna be parallel to the other half of my V. Remember before I drew something that was parallel to this one here? Like this one was parallel to the first half, but now I'm focusing on the other half, right? And then now, same thing. You just connect them. So first, I'm gonna connect Vx and Vb, Vx and Vy, and then finally, let me remove x and y now because I think you understand the pattern we're going for. And then I'm gonna connect these two, making sure that I can draw something that is as much as parallel as possible to the first blue one, the first blue lane, and then I connect them two. And that's how I represent the second version, the flip version of my first compound. And of course, now we're gonna add all the actual equator. Remember, I'm gonna start here. I like to start in this position. If for actual, I'm gonna alternate. I'm starting with up, the next one will be down. After I'm gonna go up, the next one will be down. Up and down. Okay? And then for the equatorial in green, I'm gonna do the same thing. This side is gonna be down. Let me make sure I put it behind so that you can see that it's down. After this one will be up. We're gonna go up, down, up. Put this one here, down, and finally up. And here are the two versions of our chair conformation. But guys, the only difference between those two, like to show that you flipped it, you flipped the molecule. Remember that anything that you had at an actual will be at the actual position will be converted in an equatorial position. So the way we represent it is by studying the numbering one carbon over. For example, here, if you start if in the first structure carbon 1 was at this position, then on the flip version carbon 1 need to be one carbon over. So you're gonna start counting here 1 and then 2, 3, 4, 5, and 6. So what it means is that if at position 1, for example, you had bromine that was in the actual position, because it's pointing up, then after flipping it, it will still be pointing up, but it will be at the equatorial position. That's why it's important. And again, in another video, we will talk about why sometimes the flip is important, because sometimes the molecule would rather be in an equatorial position, in the most stable position. But here it's all about drawing. I hope this video helped you. It's all about practice. Just do it multiple times. Again, we watch the video, and I think you should be fine. You should be ready to move on to the next topic. Well, now we're gonna learn how to match a chair conformation with a cyclohexane, but given in the hexagon conformation. Okay. And that's all I have for you guys. Thank you for watching the channel. I hope this helped. And remember, it's all about practice. Keep practicing until you get comfortable in it and you're ready to move on to the next topic. Thank you again. See you on the next video.